Recording. Okay, so let me share my screen. And let's start. Yes,
have you started recording?
Yes, I started recording. What I will do is I will stop, and please remember me to restart the recording. When we do exercises, I will stop. We save time so that the program is much, the recording is much efficient. Okay.
Oh, okay. Because I have a message from you, but I didn't want it to be recorded.
Oh.
Yeah.
You know, can we just put the, let's say that, move the camera, remove the camera.
Okay, I've removed mine. I guess I'll just tell you after class. It's from one person from the faculty, the message, but it's fine.
We just, you know, the other thing is simply to, I see, just move the camera, turn off the camera. Yeah, perfect. And then this is better for a recording. It's much better, guys, because we see only the MATLAB when we do the recording now. Okay, it's good for everyone.
Yes, good.
Perfect. Okay, guys. So let's try to go back again to my pro. Remember, we had this IDH. So let's try to recover IDH. Hopefully. We had one that was called IDH gender, I think. Oh, no, we don't have it. So, okay, so we have IDH. Oh, wait a second. Yeah, I can have this one. Okay, I will create IDH. I don't know if you have them, but let's create, guys. IDH is going to be 7. So it's going to be 1, 2 size of H, comma 1. Transpose, and then I have H together. So let's have this IDH. And do I have gender here? Oh, here we have gender. So and I will add gender to that. So, and I will create my IDH gender. Then it's going to be a matrix. I don't need to do that, it's already, so you have it. It's going to be IDH, and then I add gender, right? So ID is 1 to 7. The age is simply the age in years. And gender is going to be 1 male, 2 female. And let's create another one, okay? So let's create income. We'll just create income. So this is going to be equal to whatever numbers, okay? For example, and I will create savings, whatever numbers, guys. And then let's create, oh, I wrote this savings incorrectly, but it doesn't matter. So now let's create, guys, one that is going to be called ID, income, and savings. Can you create this one here, please? Simply is going to be joining these two.
Professor, can you please just show IDA, how we create IDH again?
Yes, IDH was, I have H. This was H. We did this last class, remember?
Yeah, we've got age. It's just I had cleared, so I'm just
Then
updating it.
IDH, yeah, IDH simply create from 1 to size of H1. So basically number of rows of H. So it's going to be, this is going to be a number that goes from 1 to 7, right? I transpose because remember when you do the sequence, it goes into a single row.
Okay. I'll transpose and then age. Okay, and then IDH. Thank you.
Perfect. And then what we do is I added gender. Also, we have this gender. You should have in the command history unless you clear your commands. If you have cleared your commands, yeah, everything disappears. So everyone is with a IDH gender, guys. Do you have this?
Our resulting matrix should be a 7 by 2, right?
No, a 7 by 3 in the IDH gender.
No, I mean the last one, our ID income savings.
No, should be I want the ID also at the beginning.
Oh, yeah. Okay.
So I want you to enter the ID and next to that the income and next to that the. Yeah,
you missed an A on savings.
Yeah, yes. Don't worry because we don't remember. This is a name only. Yes, I realize that. Yeah. I just need to be careful here to write as I wrote before. Income, an income is also a row, so I need to do this. And savings, I need to write this as I wrote. Yeah, that was a mistake of typing. Do you have these guys? So I have my income and savings. Do you get it? I need everyone to be with me because we're going to do a lot of exercises. This is the way data handling works, guys. Okay. So we are going to do a series of exercises. I want you to work them. I just
Sorry,
want.
Professor, can I just ask the length age again? Why do we do that?
Oh, because I want to. What is the length of A? Is basically gives you the maximum dimension of H. H is 1 times 7, right? No, 7 times 1. So length is going to take the maximum of 1 and 7. It's going to give me 7. Do you agree?
7.
So
outcomes.
Right. Instead of using size of H1, that is the same. Remember, this is the size of H1 means rows, number of rows. You see that? 7. I can use, I know that this is a row. So if I put length, it's going to give me the total number of observations. You see?
Okay.
This is different way of doing that. So you need to be managing which one do you prefer. You know, I always prefer the size, but just to show you that this works very nicely also. Ready, guys? So now what I want from you is create 2 matrices. Create one matrix that is going to be income male, and you write whatever, and then another one that is income female. Okay, so the idea is the following, guys. Take a look. You have 2 data sets, okay? Imagine these are big data sets. It's the same. You have, what is the linking between these 2 data sets? The ID, you see? Here in this data set, you have the IDs, and here you have the IDs. So these 2 data sets are linked. Now, in one of them, you have age and gender, and in the other one, you have income and savings. Make sense to you? And sometimes, guys, that the data files are so big that you don't want to join them. You want to work with them independently. And that's what we're going to be doing now. So we're going to be joining 2 data sets. We're going to be working with 2 data sets. to find different matrices. Okay. So what I want from you is the following. I want you to create a matrix that is going to be called income male. Well, it's going to be a vector actually, and income female. So you see from here, for example, income male should be income male. I need to check. I need to find first the males in here, and then I need to link into the income. Do you agree? So let me do one, so you can take a look to what I'm doing. So where do I want to have the data from? So my question is asking for income. So which matrix I'm using? ID age gender or ID income savings?
Income savings.
Yeah, because I'm asking, so I want you to give me the return is going to be this one here. So I close. Okay. Now, what column I'm going to be selecting? Where is the income?
The second one.
The second one. Correct. Now, what rows I will be selecting?
The one with one.
With females. No, sorry, with ones in the age gender group. Do you agree?
Oh, okay, yeah.
Do you agree or not, guys? Because in this one here, I don't have gender. Where I have the gender is in the other table. Make sense to you guys? So basically what I need to look from here is I need to look for this one here. I need to select the columns from this one here. Now, what condition I need to satisfy? First of all, which column I need to see from this matrix?
You're looking
Everything,
at the third column.
yes, everything third. And what I'm looking for is what?
Isn't it? Is two for males or is one males?
One for males.
So it equals to one.
That's it. Completely right. So this is going to be the income for males. Do you agree? So let me copy this out. Do you agree with that, guys? Take a look. Income male. So I will use this matrix that contains the incomes, column 2, but I will use the information from the other table that is the one that gives me the relationship between male and female. And then if I see this, I can click this. It's 2,100, 1,800. So this implies that the first two are male. Yes, completely right. You see? Then I have the next male is 1, 2, 3, 4. So the next one is 1,900, etc. So it works. Make sense?
Yes.
Okay, guys. Okay, so now you do the income female. Ready, guys? Well, the easy thing to do is simply, I will delete this one here. The easy thing is just arrow up, and then instead of male, I write female. And the only thing that changes here is what? Is this definition, right?
Yeah, you have to set that equal to 2 instead of 1.
Yeah, exactly. And that's all, right?
Yes, that's it.
That's it. And here you go. So now, guys, can we talk about, for example, give me the maximum salary of the income of males. Give me the average income of females. Okay, let's do that. So what I want is the maximum income of males and the average income of females.
Professor, you said you wanted the maximum income of males and
Yes.
the average income of females.
Yes. So let's call them max income male something, and the other one is going to be mean income female. Ready?
Yes.
So basically, guys, if you have this variable already, it's easy, right? So this is going to be the max of this one here. And the other one is going to be the mean of income female. Right, guys? Oh, well. Yeah, I can check. I can take a look at this one here. Can you put them in a, let's call info one, and I want this to be in a row vector. So I want a maximum of income male to the left, and the female mean income to the right. So a vector, 1 times 2. So basically what I'm saying is we can do this, right? Do you get this one?
Yes.
Perfect. Question. So you can do another one. Now what I want is a table like this, okay? But with the average means for men and for women. Average savings for men and women.
Professor, do you mind repeating what you want?
Yes. So what I want is I want a matrix, a vector like this, but the first row, the first column, sorry, is going to be the average savings of male, and the right one is going to be the average savings of women.
So we will have to create the
savings.
new, exactly, yeah.
Yep.
Okay.
Now, guys, remember, 1 second, before you do that, this step here is optional. Do you agree? Take a look to what I can do also. So we'll copy this one here for a minute. So I don't need to do this. I can do directly mean income female. So this is my variable. What I do is simply I do the mean of this one here. Do you see? So the trick is always work first identifying what you want. And once you have identified what you want, you can simply apply any operator that you want. You see that? It's exactly the same. So what we have done is we created, this is clear, it's cleaner. Do you agree? So first I create a variable, then when I create a variable as input, I put this as an input. It's clean. But the other way of doing that, normally my programs look like that. And sometimes I have issue understanding what I have written, but this is, indeed, when you have a small program, guys, this one here is as efficient as this one here. But if you have a program that uses a lot of data and memory, it's better instead of have a 2-line code, just do 1-line code, like this one here. It's exactly the same. So let's take a look. So we'll call this female one, okay? Just to be sure. Look, 2133, here we go. It's exactly the same. Okay, now do what I ask you guys. So average savings for males and females. Oh, you know, I need to stop the recording to do this. So we recording. Okay, so what I want now is not the income. I will use this one here. It's not the income of males, but the savings of males. Okay, we'll do this in the steps. Do you agree? So the
Yes.
savings are in column 3 of this matrix. So I need to change this, and everything else is the same, correct? So
Yes.
I do. This one here selects the males, and then this selects the column of this matrix. That is my saving. Makes sense to you? Are we sure? Then I can do here directly. So we'll do this in a single line. I use mean of this stuff. So I can change the name to be mean. Well, but you know what? Let's do it in 2 steps better. But you know you can do that. Okay. And then I have savings female. Well, where's the income of female? I can copy this one. And it's going to be now savings. So the only thing that I need to change again is this number 3. And then what I will create is my vector results. Let's call this info2. And this is going to be a vector of 2 things, right? Well, I can do the mean if we want, but I will do this directly. I will do the mean of saving male and the mean of saving female. Do you agree with me, guys?
Yeah.
Yep, 275 for
Yep.
33. Everyone got these numbers?
Yes, I got that.
Yes.
Perfect. So now, guys, I want you to just for fun call it info2, and I want the first row to be info1, to be this one here. The first row to be this one here, and the second row to be this one here. Got it? So this is going to be info1 and info. Now, if I write this one here, it's going to be 1 next to the other one. I don't want that, right? I want 1 on top of the other one. So what I need to do here?
A semicolon.
A semicolon. And that's all, right? So why I'm teaching you these guys, because once we start doing the programs, you're going to be collecting information. And the way you collect information is you create matrices with a bunch of information. And then this is the one that we're going to be exporting.
Why did it went with scientific?
Oh, because I think my definition, I don't know is what format I'm using. I think I'm using, what format I'm using? Yep, so no, I don't want that. I want format short. Yeah. Oh yeah, we can use format bank. We can use anything. But yeah, I normally use this one here.
Okay.
But you can do also format bank, I think. Format. Yeah. You see?
Mm-hmm.
I always prefer to work because I'm not seeing the individual numbers, and I prefer to be more precise. The more precise one is this one alone. Okay, so let's do a couple more exercises for you. I want to be sure that you get it. Now, I want you to tell me, guys, what is the gender of the highest income individual? Of the individual that has the highest salary, the income. Okay, let's call it gender highest income. So I want the gender of the individual that has the highest income. So basically, what is it? So the highest income is going to be 2,500, right? The third one, and the third one is going to be a female. Yeah. So you know the answer, but I want you to ask the MATLAB to tell you that. Yeah.
I got the number 25,
two.
not the number 2, meaning it's a female.
Female, yeah. Okay, 1 minute and then we solve it. But guys, you need to do this, okay? We need to be able to do that. Okay, so first of all, where the data is going to come from, the final data. The final data is going to come from this matrix, right? From ID, age, gender. And gender is the third one, correct? So I know this. Oh. I know this, correct? Now what I need to do is I need to select the rows. Now, the matrix that has the income is the matrix that is named, this one here. Income is column 2. Yeah, it's going to be this one here, correct? So I have all the rows, second column, and what I want from here is what, guys?
Maximum.
Exactly, to be the maximum of this column, right? So the max of this column. Okay, guys. So what it's going to do is it's going to provide me the information of row 3 from the one that has a gender. And what it will do as a selecting mechanism from the rows is going to do the savings column 2 that contains the income. Find the one that is equal to the maximum. You agree? Now what I want, and I think with this we can continue. Now what I want from here, guys, is the following. I want the ID. Listen to me. I want the ID and the age. So no, let's do ID and age of the individual with the lowest salary, with the lowest savings. ID and age of the individual with the lowest savings. So I want ID. What was going to tell you? ID. I'm sorry. ID. What else I ask you guys? ID and age, right?
ID
And age.
Yeah. Mean
of
savings,
lowest
right?
saving.
Yeah. Lowest. Yep. You know what? Why don't we include also the gender?
Mm.
Okay. So let's do the ID, age, and gender of the lowest, the person that has the lowest savings. Okay, so the information comes from this one here, right? And from this one here, what I want is all the columns. I basically want all the columns. You can write 1 to 3, or you can write the columns that implies everything. And now, what I want from here, let me move this one here. I can copy this one. That's a beautiful problem, right? There are things that you have done easy. So what I want from here is not column 2, it's column 3. And what I want is not the max, but the minimum, also of column 3. What do you think, guys? Works or not?
So, oh, does that colon mean 1, 2, 3?
Exactly.
When you're
So
looking at the age, okay, because
yes.
I did it the other way that you showed us. Okay.
Yeah. So because remember, we want to show the ID is the first one, age and gender. So if you want to change the order, in that case, you need to change the order here. Okay. So for example, I want first to appear gender, then to appear age and ID. So we can simply do 3, 2, 1 or something like that. Works?
Yes, it worked for me.
Yeah, it works.
Right.
Yes,
It
I got
is
that.
right. It's the first position, is the first individual. He has 21 years old and he is a male. And let's take a look. Yeah, this is the lowest one. Yep, correct. Makes sense? And what we do here, guys, with these small samples, we're gonna be able to do with huge data sets. Okay, you're gonna see it's exactly the same idea. Make sense to everyone? Yeah, let's create, for example, now let's create X to be 1 to 10. 1 to 10, that's okay. And let's transpose this one here. Let's do some sorting. When you do sort, guys, sort of X, example, well, it's not going to do anything because the default of sort is going to be ascending. Make sense? So if you do sort descending, so what you do is descend. So it reverses. So can we call again IDH? There is another command that is really useful. It's called sort rows of IDH. And then the 1 implies the number of column, the column number. So sort IDH with column 1. When you do the normal one, this is ascending. So this is nothing is going to happen. Oops, what I did. Nothing happens, you see, because I'm ascending on this part here. Now, if you want descending, you simply write -1. Okay, so if you want ascending is the number of the column. If you want descending, you simply do the negative of the number of the column. So we can do the same. Let's assume I want to do this by the second column now. Ascending. Here we go. You see now our ascending variable is the second column, this one here. 17 is the youngest guy, 25 is the oldest guy. And if you want to do this in a descending way, you just do the minus, and you can see the oldest guy of the second column is 25, and the youngest guy is 17 of the second column.
Prof, can you just explain the 2, what the 2 does?
Yes, the 2, when you have a matrix like this one, it can be 3, 4, 5, whatever matrix, whatever number of columns. So if I want to sort based on the second column, this 2 implies the second column, this one. Got it? Now, if you write a positive number, what it does, it sorts in ascending order based on the second one. You see here is in this order, 17, 23, but here is 17, 18, 19, up to 25. When you have a positive number 2, it orders positively, sorry, ascending. Now, if you want to reverse the order, so I want the largest to be up, etc. So you just do the negative of that.
Oh, so it's sorting according to the second column.
Yes, exactly. Positive implies ascending, negative implies descending. Okay, guys, so now let's go into some logical operators. Are you with me up to now? Today we need to start working our hopefully our first programs. Are you working with me? Are you with me, guys?
Yes.
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 Okay, so now what we are going to be doing is logical operators. Okay, we have done one already. So this one here implies equals, right? This one here, guys, the ampersand implies and what is this one here? This one here, the vertical bar implies or. Got it? So we have equals and, so one condition and another condition. One condition or another condition. We're going to do exercises with that. Then we have something that is we use a lot is NA is NaN. So this one here identifies, guys, if you have a not a number. This one here identifies if you have empty spaces. Okay, if you have empty, imagine you have data, a lot of data, and you want to identify where do you have spaces, empty data. Okay, just imagine Excel, you have number, a cell that is blank, number. So you want to select which is this empty
Sorry,
cell.
Prof.
Yes.
The previous one before is empty. What does that stand for?
Which one is none? This one?
Yeah.
It's not a number. So it's basically an undefined number. So imagine if you divide a number divided by 0, it's undefined. Do you agree? This is this one here. Okay, now we have also is infinite, an infinite number, etc. We are going to see how this works in a minute. So remember, these are logical operators, guys. So it returns zeros and ones, always. Okay, so we can do one example. So let's create something that's very easy. So let's do 8 equals 1 to 9. I think we can do this. And let's do B equals, let's say 10 to 19. You know, better A minus. Let's do 9 minus A. So let me show you what is A. This is A and this is B, just whatever number. Okay, so from you, what I want you to find, guys, the values of A that are not equal, that are not larger than 4. So let's call this EF equals. So what I do if I do this, to remember? What happens if I do this one? This is a logical operator. So what happens?
Yeah. Where A is greater than 4.
Yes.
Yeah.
So basically, it will create. This is A. So it will create what? So tell me what numbers you expect. Don't run this. I want you to know the logic already. So this is a
First one will
logical
be 0.
0, 0, 0, 0,
0,
1,
0,
1, 1.
0, and then 1. Yeah.
1. Exactly. Let's see. Oh, I don't have. Okay, it's a small A. Here we go. Now, what I'm telling to you is find the values that are of A that are not larger than 4. Of course, this implies smaller or equal than 4, right? But using one of the ones that we have seen, one of the logical operators. What we can do, guys, is this one here implies a negation of a positive, so it's not. So this is that, right? Make sense?
So this
Why
is
am I
trying to
keep that? Can
find,
you repeat that?
So this one here, basically, guys, is the same as saying A is smaller or equal than 4, correct? It's exactly the same. But this one here, this notation here, I need you to get familiar with this one here because it is the negation of something that you have inside. So these are the numbers that are larger than 4. Negating this one here implies this one here. All the numbers that are smaller or equal than 4. Got it? So now what I want from you guys is the following. First, identify the numbers of A that are larger than 2 and smaller than 6. Okay, in logic terms. Then I want you to identify the exact numbers that are larger than 2 and smaller than 6. And the last question is, I want you to tell me how many numbers in the A vector that are larger than 2 and smaller than 6.
May you please repeat that?
Yes. So the first thing that I want is I want to know the logical values of this, of finding the values that are on A. We just want to work on A. That lowers my A. Here we go. It was A. Here we go. So what I want is that the values, I want to identify those values that are larger than 2 and smaller than 6. So basically, I'm talking about these numbers. So I want 0, 0, 1, 1, 1, 1, 0, 0, 0. This is the first question. The second question is, I want to know these exact numbers. 3, I want you to compute, I want you to show me basically 0, 0, 3, 4. No, I want you to show me these numbers, 3, 4, 5. And the last question is, tell me how many numbers that are larger than 2 and smaller than 6. The number, how many observations do I have? Well, you know the answer, but it's going to be 3 in this example. Okay, 3 minutes to do that. I will stop the recording. Please remind me to. Yeah, well, yeah, let's redefine from find. So what find does, remember guys, what find does is a new command. Where's my find? Here we go. This find command, what it does is instead of a logical 0, 1, what it does is basically determines the values, determines the positions where the condition is satisfied. For example, K here, I'm finding the values, the absolute values of X that are larger than 1, obviously are these two values here and these two values here, and you can see the positions. Position 1, position 2, position 6, and position 7. So that's the idea with the find command. Got it? Now, if we, for example, to remember here, we have an NA here. When you use the logicals, you're going to have a 0 and 1s, but it doesn't give you directly the position. So either you count or you do an or if conditions, for example. But we can do this. We can find the exact position of the NA using the find command. That's what I'm doing. K1 equals find is NAQ, and you can see it gives me the position 4. So take a look. 1, 2, 3, 4. Position 4, I have an NA. So that's why the find command is very useful for finding positions. Now, what I was telling to you is the following. What I want, here we go. What I want is not the positions, not only the positions, but what I want is the actual values of X that satisfy a given condition. So in that case, what you do is what we have done as similar to what we have been doing with logicals. Simply say, this is the vector I want, and just take these positions. It's very simple. K are positions, so you simply take from X these positions, and it provides you the numbers that you're looking for. These ones. and these ones. Got it? Also, you don't need to do the K first and then replace the K on this equation here. What you can do is directly. So you say from X, find the positions that satisfy this condition, and MATLAB is going to provide you immediately the conditions that we're looking for. And finally, guys, I was telling to you, what if I want to keep the same structure like the original matrix? So I want to have this number, 0, 0, 0, this number. So the trick is very simple, and I use this a lot of times. What I do is I take my original matrix, X, okay, so this is my matrix. And what is this one here, guys? What is this going to produce? Absolute of X larger than 1. So what this is going to be producing? This is a logical, right? There is no find, so there is no position. This is a logical command, correct? Guys?
Yes.
Yes.
So logical always returns 0 and 1. So basically what I'm doing is I'm multiplying X times, where's my, times, well, we don't have this, times, is going to be 1, 1, 0, 0, 0, 1, 1. Got it? If you multiply that, all these numbers here are going to become 0, correct? And take a look to what happens. Makes sense to you guys? So we can continue. Makes sense to you what I've done here?
Yeah, because you're just multiplying by ones and zeros.
Exactly. So the conditions are not satisfied. The zeros, they disappear. The numbers don't disappear, sorry. They become zeros. Completely right. That's all what we have done. Okay, so now what I want from you guys is, let's call again my IDH gender matrix, okay? And now what I want from you guys is using the find command. Don't use the logicals, okay? Use the find command. I want you to tell me the okay to drink. I want the okay to drink. All the information. So basically, one ID, age, and number of the okay to drink. Remember, okay to drink in USA is all the people that is older, 21 or older.
So are we just getting the individuals that are
Older than 21.
all 21? Yes.
Yeah, remember, it's okay to drink here in USA.
I was thinking my country. Yeah.
18, right? Your country?
Yeah, my country. Okay.
My country is also 18, yeah. What is it? What about South Africa? What is the limit
It's
age for
also
drinking?
18.
18, yeah.
I think it's usually only the US that's high because it's 18 in the Bahamas too.
Yes, no, I agree. Yeah, but no one does the rule here in USA. 21 years old. Well, but it's interesting also. In my country, if you want to drive, you need to be 18 years old. Here in USA, 16 years old. Have you realized that?
Yeah, it's 16 to get a learner's permit back home for me
Yeah.
too.
Oh yeah.
Same with us.
Say 16 also?
Yeah, to get your learner's license.
Ah, interesting. No, my country is 18 years old. Otherwise, you don't do anything. Okay, guys, you tell me. So that the logic is always you need to think, okay, where's my data? Okay, the data that I will export. Remember that you can have a matrix that only you are using for getting information. You're not using for exporting. Okay, so this matrix here is the one that contains the information that you have. Make sense to you? Now, what I want to report? Well, I want to report all the columns. Great. So I just need to focus on the rows. Now, what rows I want to select using the find command. So I want to select the ones that are in the second column, larger or equal than 21. So it's going to be find of a what? Find my vector, my matrix, sorry, second column. And I want this to be larger or equal than 21. So I need to close my find because my find has parentheses. And this is it, right? What this part does is finds me the positions. Make sense?
What if we would only put the command you had selected?
Which command?
Like only the find IDH.
Oh,
Gender.
it will give me the position. So let's take a look. So basically, it's giving me the rows. So it's giving me 1, 3, 5, 1, 3, 5, and 6. So these are the rows that satisfy the conditions. Now, guys, if you want to find the exact location of these ones here, because this is a matrix, right? In a matrix where you need to identify, it's not one is very loose. So if you want to find the exact position where these numbers satisfy, you do IJ. Oh. Oh, well, because I have only one row. Yeah, I will do another example to show you this in much clearer. Okay, forget about this for a minute. Make sense to you guys? Make sense to you this way?
It does, but my thingy doesn't pick up. It says unrecognized functional variable find.
What?
So-
It gives me an error that says unrecognized functional variable find.
Wait.
Mm.
Wait, can you try to run this one here? Yeah, that can be really insane if MATLAB. And you try to run this one here. You were working with find already, right? Before? It worked, right?
Yes.
It worked before. So no. So you made a mistake on somewhere.
A problem.
Yeah, can you take a look if this works?
It still says it doesn't recognize it.
Oh, are you sure you have this ADH gender active? Can you click there?
Yes, I do. I did even.
Yeah, can you show me your screen, guys? 1 second only, because I want to be sure that everyone is with me here. What is that?
Oh, okay, it works now.
Ah, it works. Okay,
Yes.
perfect. Yeah, perfect. Give me 1 second now. What's going on here? Okay, guys. Yeah, you know, there is an additional thing that you need to do. Well, the last one. Okay, the last one. Just I want you to select. You have selected here the IDH number. Okay, to drink, but I want to do the same. Only females. I want you to tell me only females. You understand? So not only 21 years old, but only females. That all the females are 20 years and older. One minute, guys.
So we would do within the fine, we would add the n condition for all the rows, the column tree equals 2, maybe.
Yeah. Yep. You're right. So this should be basically something. This is equal, right? But my find command, where's my find command? Here we go. My find command is in parentheses, right? So I can put as many conditions as I want here. We'll copy this one here. And then I need to use the logicals. In this case, and it is not anymore the column 1, is going to column 2 is going to be column 3, and I want this to equal to 2. So what I'm saying is find all individuals that are older than 21, older or equal to 21, and so at the same time are females. Ready? Here we go. Okay, I want to give you another example, guys. Can you please, let's work with this matrix A. Can you enter this matrix A, and then we're gonna do exercises with this one here that are really interesting. Ready? Are you with me now?
Yes.
Okay, first guys, I want you to find me the position of the number 8. The exact position of 8. So for the exact position, you need to have rows and columns, right? So you need to do something like that. You need to do I and J, so this is row and column, equals find, and then you find whatever you want. So I want you to give me the exact position of the element 8. Of course, I know there's a 3-3, right? The position is position 3-3. Okay,
Yes.
but I want you to find this using MATLAB. Ready? What positions have you been able to find it? So I don't know what variable to call. Let's call this C. C equals, sorry, no, it cannot be C. It should be I and J. You can name it as you want, guys. Huh? I and J is going to be equal to what? Find column 8 equals 8, right? That's it. Agree with me or not, guys?
Yes.
Yes. Here we go. Third
So
column. Yeah.
when we use beforehand I and J, we are asking already the row and the column.
Exactly. So if you just do, for example, let me do this. What does is 11. So how MATLAB counts all the programs, R, Python, everything counts this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what these guys do basically, guys, is can you do ABEC? Let's call this ABEC. It's going to be the vectorialize of A. Oh, you don't have vector of A? Oh, so this version doesn't have that. So it's A. Yep. So basically what MATLAB does is puts all the values, all my metrics, you see that? Orders that in this way. And then it counts like that. Right? But it's basically saying 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. It counts in a vector ways. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You see that?
Okay.
Makes sense? So it vectorializes. So when you have a simple A, you just want to know the position. So you need to know it's more complex. That's what I'm saying, 11. But you need to remember that MATLAB puts the first column, the second column goes down, and the third column goes down. So this is a vectorialization mathematical tool. Okay, so that's why it's much better if I have my IJ, so I have something that is something I know how to read much easier. Got it? So let me write A again. So now, guys, what I want from you is to select the columns, all the rows, all the columns with rows equals 0, using the find command. All the rows that start with 0, these ones here. So I want all this row and I want all this row.
All the columns.
Yeah, so all the columns of the first element being 0.
So it's only I then, not I, comma J.
Yeah, okay, fine. When you do the find, MATLAB does this for you, so you don't need to worry about that. A and J, MATLAB will find this for you. Simply set a condition. So let's call A0, okay? Okay, so basically what I'm saying is where I will get the data from A, right? All the columns. Sorry, yes, all the columns. What I need to select. If I use find A equals, sorry, what A, which column of A? All rows, comma 1. I want this to be equal to 0. Close my find. Agree with me or not, guys?
Yeah, agree. I just didn't, why did we use the last colon?
Oh,
Because you want all the observations.
exactly. I want all the columns. I want all the columns from A. So this is the one.
Okay.
So that's why remember when I start doing this stuff. So let me go back. Always, this helps me a lot, guys. What I do is, where is the data coming from? From A. Okay, what columns do I want? I want these columns. Got it? And then the only thing that is missing is the rows. And then I set my conditions and then I get what I want.
Prof, what was the question?
Oh, here my question was select from A, select from this one here, all the columns of the first of the elements of the first column to be equal to 0. You know, so what MATLAB is doing is find this one here. Find first of all the columns. Sorry, in column 1, all the rows that satisfy the equal 0 condition. So it's going to find this one and it's going to find this one. And once they identify this position, you simply say, okay, give me all the columns of my matrix A. Is this one here? Okay, guys, up to here is going to be your second assignment. So you're gonna have time to do the second assignment with the find. Yeah. Yeah, I think that the second assignment, you're gonna be able to do that already. Yeah, you're gonna be able to do that. Okay, guys, questions, so we can continue. Okay, so now let's do some linear algebra, because linear algebra is what we're going to be doing all the time. So let's assume that I have an array, very simple. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. A very simple A. Okay, so from here, guys, for example, I can say A1, I want to be A of 3,3. So what I'm doing here?
Isn't it you trying to find the value in that position?
No, I'm not finding. Remember, if there is no logical or not find here, this is I'm selecting a specific location from this matrix.
Okay.
So what I'm doing is basically selecting the 9. Oh, I have 9. You see that? So when there is no logic or find in between the parentheses, so this means simply we are looking for specific information in the matrix. Now that we have talked about the vectorization. Okay. So the vectorization, guys, simply works. I have the first column, then the second column goes down, and the third column goes down. How can I recover my A? So this one, let's call this A1. How do I recover my A, guys? If I have vectorized a matrix, how do I go from here to here? How do I come back to here?
Is there a way to put a negative column?
No. In that case, doesn't work. Give me 1 second. Where is that? Nope. There is something that we have used, guys, reshape. You remember that? Reshape. We have done that. Reshape, in this case of A1, and I want this to be a 3 and 3. And that's the way you recover shapes.
I don't think we've used that before.
Oh, we haven't? Oh, sorry, guys. So this is the new command. Sorry, I don't know what I have taught you.
Yes, this is new.
Okay. Okay, so there is a command that is very beautiful. It's this one here, reshape. Okay, so what does reshape does is basically organizes the data in a different shape as the original one. For example, the only thing that you need to remember is that the multiplication of these two numbers should be equal to the number of observations here, always. So I have a 3, 3, 3. Okay, so what I'm saying is reshape A1, that is 9,1, in a vector, in a matrix that is going to have 3 rows and 3 columns. So basically, it takes the first 3 elements, first column, the second 3 elements, second column, and the last 3 elements, last column. You see that?
So you can create whatever you want, not just the original.
Whatever you want, but the thing is that this number, if you multiply these two numbers, so this basically, if you multiply the number of columns, number of rows, it gives you the total number of observations, correct?
Yeah.
So that's the only condition, that the number of observations here is exactly the same as the number of products here, as a product of these two numbers. That's the only condition. So I'm trying to find your assignment. Give me 1 second, please. Yeah, I send you the assignment number 2. Okay, so let's do some matrix algebra, guys. I think that if we more or less understand matrix algebra, we can start doing our programs. Today, we're not going to have to do programs, but we are very close. We are really very close. So we are good. So now we're going to start programming seriously. Okay, so what other properties that we have? What are the things that we do? Oh, yeah. This is something that is really good. So, okay, I put A again. So imagine, guys, that you want to select. Let me see. Yeah, we just as a matter of practice. Can you please change the number of columns? Remember, the first column, the last column to be the first, the second, the first. Can you do that? And the same with the number of rows. I want the last row to be the first row, the second row, the second, and the first to be the last one. Remember, this was playing with the indices. Can you please do that very quickly? So let's call B1. B1 is when you shift the columns, and B2 is going to be when you shift the rows of A. Okay. So do you remember? I want from A. How do I shift the columns? So I will have all rows, right? I keep the same rows. What I do with the columns?
I think you subtract 1.
Yeah, but where do I start?
On the third one,
Three.
third
Third one.
from 3 to 1.
3. Sorry. 3. What else?
-1.
-1. I need to do -1 and 2, 1, right? Now, but I don't want this 3 because if my matrix changes, I will need to be always typing this one here. So what I can use instead of the 3?
End.
Yes, I
End.
can use the end, or I can use the size number 2, right? Or I can use the length because it's a square matrix, so it's going to be the same. All right. So now let's do B2. In B2, what we do is I want to what the changes are going to be in the columns, right? Sorry, in the rows. The last row is going to be the first one, etc., etc., etc.
Prof, didn't you say you want from the initial one? You wanted
Yes.
the rows to swap the rows and also to swap the columns.
No. Just one is the columns. This one is the columns, and this one here is the rows.
Okay.
Take a look. You see the 1, 2, 3. Now is the last one. Well, this was the first one. Well, this is the same, and this one here was the last one. Now is the was the last one. Now is the first one.
Because initially I thought
Yeah.
B2 would be then A, and then you open the bracket.
Oh yeah. You
and
can
then
do.
when you
Yeah,
start
I
with the
understand.
rows, you say 3 minus 1, 1, and then comma, and then
Oh.
you do the same for
For
the
the other
column.
one. Yes,
in-
you can do that.
yeah,
It's
all in
a
one.
different exercise, but yeah, it can be done. But this is a different one. Huh? It's a different
Yeah,
question.
because now I'm looking at my outcome. It's not the same.
Completely
as what
different.
you
No,
had.
no, it's going to be completely different. But you understand. So
Okay, please
that's
repeat.
basically
Please
it.
repeat what you said you want.
Oh, I wanted, this is A. So B1
Mhm.
is going to be the change of columns. So 369 is going to be the first. Well, 258 is the same, and 1.145, 147 is going to be to the right. You see, shift the columns.
Okay.
And B2 is going to be shift the rows. You see, 1, 2, 3 is going to be the last. 7, 1, 7, 8, 9 is going to be the first.
Okay. Got it.
Got it?
Mhm.
Perfect. Okay, so now, guys, one thing that is really interesting is let's take a look to B2. Okay, so what I want from B2 is only use the first and the last column. Got it? So basically what I'm saying is I want to delete from B2, I want to delete the second column. Make sense? So what I will do is the following. B2, all rows, second column is going to be equal to bracket. No, this is not correct. So what I'm saying here, guys, you need to be very, very careful here because now B2 is going to disappear, okay? In real programming, guys, you need to be very careful. If you don't want to modify permanently a matrix, better if you do the following. B3 equals B2, for example. And then I keep B2, and then I can use B3 and delete whatever I want. Makes sense now? Take a look. You see what I've done? I have disappeared the second column. That's the way you select only the ones that you're interested in.
We could have also just kept the first and third column too,
Yeah.
right?
Yeah, definitely. But this one here is much easier. You see that you don't do conditionals, you don't do logics. Well, actually it's very similar. But this one here, the only thing that you need to be careful is that when you delete this one here, you cannot recover what you have deleted. You see that? So that's why normally what we do is this one. You create a new matrix. So B2 is B2. So if at a given point in time you want to recover B2, you have it. You see that?
Okay, I get it.
Yep, perfect. So now, well, we know that the size and the length. Any questions about size, length, guys? It's nothing, right? Now, can you tell me how many observations do I have in B2, in B3? Number of observations that I have in B3.
Length, B3.
Yeah, well, length is going to give you the maximum of 3,2, right? So it's going to be what? It's going to be 3. Length of B3 is going to give you 3. So how do I know that the total number of observations? We did that before. What if you have size of A?
Is it not size?
Yeah, size of B3 gives you what? The rows and
dimension.
columns, right?
The dimension, yeah.
Right. But then what you can do here, guys, is basically what if you do the product? Because these are numbers, right? 2 and 3 are numbers, or 3 and 2 are numbers. This is the way, guys, in which you obtain the number of observations in general. The product of the rows and columns. That gives you the number of observations. Okay. So now let's go to A. I will call, there is a command, guys, that is called the flip. What we have been doing left to right. So basically what this is going to be doing, guys, is what we have done. Left to right implies that the last column becomes the first one, etc., etc., etc. So this is this is my command flip left to right. So instead of doing the -3, etc., 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 or the 3 minus 1 to 1, this is the MATLAB command. So let's do now the up and down. So A up and down. So this is flip up and down. And provides you this one here. Make sense? So guys, I want you to select from A. Let's call this A3 or A1, I don't know. Let's call it A1. So all the rows 1 to 2. There is a command that is called, let me call this A2, that simply rotates 90 degrees counterclockwise. So take a look to what happens. I never use it, huh? In real life. I never use it. This is something cool on me, but I haven't used it seriously. So what it does, it rotates. You see, 90% counterclockwise. A complete matrix is rotated. You see, the 1 goes down, the 2, etc. Another thing that you need to remember is, for example, let's do have A 1 to 4. And if I use diag of A, what we're doing is this operation, guys, is called diagonalize the matrix. So you have 1, 2, 3, 4. When you use diag of A, what it does, it puts its values, these values here, in the main diagonal, and zeros otherwise. Okay, now imagine that we have A, big A. Also, diag, guys, give you the elements of the main diagonal of a matrix. So, for example, diag of A, 159. You see that?
Can you scroll up a little bit to
Yeah, definitely.
you?
Rotate or which one?
Okay, no, I just wanted to see how you got the one that had the zeros. But that's
Oh,
just
yeah, yeah.
you
It's
put a
diag.
vector. Okay.
Right. You have a vector, and then you diag this vector. Basically, takes every single value that you have in your vector and puts this in the main diagonal.
Please explain how rotate works.
How, what again? Can you repeat that?
Rotate.
Oh, yes.
ROT.
Rotate, yeah. Rotate 90. Is ROT 90. So basically, take a look to the matrix. 1, 2, 4, 5, 7, 8. What it does, it rotates 90 degrees counterclockwise. So, you know, the clock goes from left to right, right? So when you say rotate 90, it's going to go from right to left 90 degrees. Take a look. So just imagine this one here, rotating this one here in this way, rotating in this way. Do you see my mouse? Rotating this way. Basically, it's going to be, the 1 is going to go down, the 2 is going to go up, the 4 is going to go down, the 5 is up, 7 down, 8 up. Simply rotates 90% of 90 degrees counterclockwise the data that you have there.
So for just like a single line vector, that could
Yes.
also work the same way as transpose, right?
Yeah, exactly. Yep.
Okay.
Yeah, now let's take a look to A1. This is interesting. So now let's do A1 transposed. And now let me bring back my rotate. You can see the difference. You see that they are different. The transpose is the columns become rows. So the first column becomes the first row, and the second column becomes the second row. This is different than have the rotate. You know, the rotation is different. You see the difference, guys, between this one here and this one here. Okay. Yeah, always the transpose, we use transpose. I never in my life I've used rotation. I know it, but I have never used it. I don't know when to use it. Well, I never thought a lot about that. Make sense?
Yes.
Okay, guys, so we don't have time to do problems, but let me, yeah, perhaps let's do some spatial matrices, okay? So we're going to be well prepared for next class. So there are spatial matrices, guys, that we have in all programs, you know. Let's call this S equals, imagine if you put 0, 3. So what it does, it creates a matrix of full zeros of a 3 by 3. So if you want a zeros, for example, 1, 3, it creates a vector of zeros with specific dimensions. So this is the zeros command. Now you have something similar with ones. So if you want a 2 by 2, you can write 2, 2, or you can write simply 2. Now we have another, in terms of random numbers, guys, we have the command rand. This is a, how do you call it? This is a uniform random variables. You simply give the dimensions. Rand is random variables. Okay, now if you have the random normal, guys, it's simply rand with an n at the end. So this is the normal standard deviation. So if you want a 3 by 3, for example, I simply do this. So these are random numbers taken from a standard normal distribution that is a mean 0, standard deviation 1. Make sense? So the last one that I want to show you is the function that is called, the command that is called I. So this is our identity
Wait,
matrix.
sorry. One more.
Yes.
What
Yeah,
was
go
the
ahead,
difference
please.
between random and random number again?
Yes. No. The rand like that, this is the uniform random distribution. Okay, the uniform random distribution between 0 and 1. So that's the definition. The rand is a uniform random distribution between 0 and 1. Now, when you add the n at the end, is the standard normal distribution. Remember that the standard normal distribution has a mean of 0 and a standard deviation of 1.
Okay.
Okay?
All right.
Yeah. The I, the ones, the zeros, I think that's all what we need. Now, let's do some basic matrix operations, and then with this we stop here. I will give you the assignments.
I'm
Yes,
sorry, Professor.
sir. Yes, go ahead, please.
Just for interest sake, what if I want random numbers? Say for instance, I just want positive random numbers from say 3 to 8.
In random, in what sense? The uniform ones? These
Yeah.
ones? Yes, what you
Yeah.
need to do is basically, remember, these are going to be between 0 and 1. Let me see. I haven't used the one. Yeah. Yeah, example, this is, oh, this is the way you do it. A plus B minus A random, this one here. Oh yeah, you have one here. For example, this is in the interval between, yeah.
Okay, thank you.
This is the one. This is the one, so we can do this. But this is not the one that I want. Wait a second. Give me 1 second, 1 second. So we need to find, this is the one that we need to do. Okay, so let me check this one here. So let's do, imagine you said between 5 and 10, right?
Yeah.
And then I have 100 observations, yeah. Yeah, I don't want 100, I just want 10. Here we go.
Oh, okay, perfect. Thank you.
All right, and then whatever you want, if you want 20 to 15, whatever you want, this is going to be the way of doing that. Okay, questions? Questions, guys? Okay, so let's do simple mathematical matrix operation. So you know what? If you want to buy A plus B matrices, the dimensions of A must be exactly the same dimensions as B, correct? Otherwise, you cannot sum. So let's say that A equals 1, 2, 3, 4. Let's assume that B equals whatever, 7, 8, 5, 7. Right? So as usual, guys, the dimensions must match. We're going to be working with this later. So, but this is, if we say C equals A plus B, you can sum them. A minus B is the same. It doesn't matter. Now, remember, guys, that we have element by element operations. That's crucial. So, for example, I have A product B. So let me remember A and B. You see that A element by element product of B is going to do what? It's going to do 1 times 7, 2 times 8, 3 times 5, 4 times 7. All right. So if we do this, this is what we get. 1 times 7 is 7, 2 times 8 is 16, etc. This is element by element. What we can do also is we have all the powers. For example, I can do this one here, element by element power. This one here. You can divide element by element, of course. For example, etc. Now, imagine that I have let's call D equals 1, 2, 3, 4, 5, 6. And then, of course, guys, what I can do is I can multiply A times B, right? What is the multiplication rule? Do you remember that? Imagine A is an M times N. So B should be what? The dimensions of B. If you want
It
to
should be
multiply
an
them.
N by anything
Whatever,
else.
exactly,
Yeah.
by P, let's say, right? So what is crucial for a matrix multiplication, guys, is this one here must be equal. So let's try to multiply A times how do I call it, D. I can multiply that, yes, right? Because A is a 2 by 2 and D is a 2 by 3. I can multiply that. But if you try to multiply A times D prime, so now I have D is going to be a 3 times 2. Then it's going to see, oops, you have a mistake there. Right? Now, there is something that is really interesting. So imagine that you have a vector that is 1, 2, 3. Yes. Now, what is E prime times E? So first of all, what is E prime? And what is E prime times E? E prime, what's my prime? Times E. What is this one here? Do you know this matrix, guys? It's very famous matrix. How do we call this matrix? Do you remember in Excel, sorry, in econometrics, guys, we have B equals X prime Y, X prime X, sorry, to the minus 1, X, X, Y. This is not mathematical notation, as I'm just writing to. Do you remember this one here? This formula here? What was this formula here?
That's for coefficients, right?
Yes, the coefficients of the simple OLS model, right? Now, this part here, what is this part here?
That's the variance,
The
right?
variance covariance matrix. Do you agree? What is the property of the variance covariance matrix, guys? That the elements on the main diagonal are what? Take a look to these numbers. What are these elements here?
They're the squared values.
Exactly. These are the square values of the numbers. So what is the square value of the numbers if the expected value is 0, guys? What it represents? It represents the variances. So that's why it's called variance covariance matrix. So the variances are going to be located, the variances, the square values are going to be located in the main diagonal. And the covariances is basically how these elements relate to the other ones are going to be located outside the main diagonal. And as you can see, guys, this is a symmetric matrix. The 2 is here, the 3 is here, and the 6 is here. Make sense? Okay, now, so what if I revert this one here? What is equal to E times E prime? What is this 14? What is this 14, guys?
Is that the dot product? Is E a vector? What was E again?
Oh, E is this one. Yeah, let me rephrase E again.
Isn't it the sum of the product of the corresponding numbers?
No, if you multiply, take a look. 1 times 2 times 3, this is 6.
No, I mean like 1 times 1 plus 2 times 2 plus 3
Oh yeah,
times 3.
the square values. Yes, completely right. That's it. So these 14 guys here is the sum of the squares of the square values. So you see 1 plus 4 plus 9, 14. So, and this is what we try to minimize in the OLS model. Remember, what we try to minimize in the OLS model is the sum of the square of the errors, correct? Do you remember that? Remember, guys, you need to remember something about this one here.
Yes, we remember that.
Okay, so basically we are starting working on an OLS model now. So, but that's the logic. Makes sense? Now, another property of the variables, guys, I is the identity matrix, right? So let's do an I of 2. So it creates an identity matrix like that. I have my A is like that. So what happens if you multiply any matrix times where's mine? Times identity matrix? What do you get? Any matrix times the identity matrix. Of course, they need to be conformal. That's the only condition.
It returns the same matrix.
Exactly. So because the I is more or less like the 1 in the scalar numbers. And what is interesting also is that A times I is the same as I times A. This is not necessarily true for all the matrices. It's just because we have the I there. Now, guys, this 14 here, or this type of matrices is called a scalar product.
Yeah.
So I have one question.
Yes,
Professor,
please
do
go
you-
ahead. Please go ahead. Go ahead. Questions.
So when you're doing the powers, not the element by element, the
Yeah.
matrices still have to be the same size for that, right?
Yes.
Okay.
Yes, because remember, yes, it must be a quadratic or needs to satisfy the condition of the MNNP. We're gonna do that, and I will show you how to do that very easily. Because one of the questions that I always had is that, for example, what is if I give you a matrix, okay? What is the square root of a matrix? It's not element by element, huh? We're gonna do that. Don't stress with that. We're gonna do all this stuff, and we're gonna put all these things together, creating our own model. You're gonna see we're building up. But next week I need to do the exercises with you, and let's start programming. So we're gonna start seriously doing programs. Our life is going to be much easier once we start programming. Okay, guys, please, if you can review all the commands that we have done a lot of commands. So just memorize the commands and make sense of them. So you're gonna have the recording hopefully by tomorrow or Friday. The beauty is that as soon as we are out of the summer class, the IT guys can do this very quickly. Now, when we start the summer class, guys, when the people start summer class, it takes normally 1 week to record this stuff and to upload in the cloud. I don't know why they do it like that. Okay?
Professor, just to confirm, we have class on Monday, even though it's a public holiday.
No. We don't have class on Monday. Monday is a holiday. It's a Wednesday. We have classes on Wednesday. Yep. So the assignment is going to be done for Wednesday when we meet.
Okay.
Okay, perfect, guys. So enjoy your long weekend, and we keep in touch. Okay.
Take care, Professor.
Okay.
See
Bye,
you guys.
Professor.
Take care. Bye bye. Have a nice
Thank you,
weekend.
Professor. Bye.
Bye, guys. Bye bye.